Hi everyone, Algebra 2 Trig Advanced students. I want to go over day 3 quadratics and what we did in class if you happen to miss that. So we're going to cover that right now. The first thing that we did was we went over this problem that we have done before, which is the fencing problem. And you have 500 feet of fencing and you are trying to create a rectangular corral for your pet pig, duck, and zebra. So we're going to call this Y and this side Y. Because this is against the barn, we're not going to use that side. So we're going to call these sides X. And our job is to find the maximum area. So the first step that we're going to do is we're going to find the perimeter. And that's going to be 2Y plus 3X is equal to 500. Okay. And solve for Y. 2y equals negative 3x plus 500. It's always important to put the x before the number there to put it in point-slope form, or excuse me, slope-intercept form. Y equals negative 3 halves x plus 250. So we're mostly going to set this up. You know what y is here. To find the area, in order to find the area, that's going to be length times width, which is x times y. Now, we do know y. This is y. This y is going to go into this equation here. So we have area equals x times negative 3 halves x plus 250. And we're going to distribute area equals negative 3 halves x squared x times this value and x times this value plus 250 x. And this is our area formula now for this equation. Looking at this parabola, if I were to draw a little sketch here, if x was 0, y would be 0. So what I'm going to do is know that this is 0 here, going up and over here. My domain is going to go from here to here. That's the domain. And this value up here is going to be our half of our domain. And also, what this is going to be also is going to be the max area. Okay, and so that's what I want to find. So basically, I would just graph this here. I can plot points and whatnot, but to find that point right here, we're going to use the vertex shortcut, which says negative b over 2a, comma, and then you're going to plug that value that you get back into the equation. And so in doing that, we're just going to plug in negative b, which is the 250. So we're going to say the opposite of that, which is 250 over 2a. So that's 2 times negative 3 halves. And then, of course, 2's cancel. So we have 250 divided by 3. And so that value, and then we have to find the other value here. So setting that up, you have negative 250 divided by negative 3 makes positive 250 divided by 3. And then you're going to work to plug that back in to this equation right here. So I'll set that up for you, and you can finish that at home. You're going to go area equals negative 3 times 250 divided by 3 quantity squared plus 250 times 250 over 3. And then you're going to close that up. And that's your area. That's your max area, which also happens to be this y value. The discriminant we talked about a couple of days ago. And what you need to remember about the discriminant being b squared minus 4ac, the discriminant comes from the quadratic formula, whereas x equals the opposite of b, plus or minus the square root of b squared minus 4ac, and this is all over 2a. And that, from the formula general equation of a parabola, y equals ax squared plus bx plus c. Now, this area, this part right here, that is your discriminant, okay? And what that tells you is whether or not your graph is going to cross the x-axis and you have real solutions or not. So basically, you can have a parabola, and we're talking about quadratics, so all of these are parabolas, you can have a graph crossing your x-axis twice, one right here, one right here. That right there gives me two real solutions. That's this right here. So when I plug my values for my equation, b squared into b squared minus 4ac, and I get a value that's greater than 0, 5, 15, 100, I'm always going to get two real solutions, meaning my graph is going to cross in two places for two real solutions. If, though, when I simplify my b squared minus 4ac and I plug the values in, I only get one real solution, that's going to look like this, okay? I have one real solution. Basically, I got the value equal to 0. So when this value inside here is equal to 0, I have one real solution, meaning it's going to cross the graph one time. To get imaginary solutions, I'm going to plug in b squared minus 4ac, and I'm going to get a negative number, like -4, -5. And what that means is that my graph is just floating. It's not crossing the x-axis at all. That means if it's not crossing the x-axis, I don't have any real solutions. I have two imaginary solutions. So practicing, we know that, again, from the standard equation of a parabola, of a quadratic, this is ax squared plus bx plus c. A being the 3, b is positive 6, and 8 is positive c. Keep in mind that you always take the sign in front of that. So in order to find the type of roots I have, I'm going to use my formula, b squared minus 4ac. And so b squared, this being b here, so it's going to be 36 minus 4 times 3 times 8. Okay, so we have 36 minus 12 times 8. 36 minus 96, which makes -60. This is my discriminant, and it's negative, so therefore, those three little dots mean therefore, I have two imaginary roots. And what that means, really, if you're looking at it and you're thinking about, okay, what does that actually look like as a graph? We're not quite sure because there's a lot of things we can do to plot points, complete the square, etc. But if I know that my y-intercept is 8, which is up here, my graph is either going to go down to the right or it's going to go down to the left, depending on plotting points. I can plot points if I want. But what I do know, so it's either going to do this or it's going to do this. But what I do know is that it's not going to cross the x-axis because I got imaginary solution. I got a negative number, which means it's imaginary. Okay, the second one, to find the discriminant, again, this is a. A is in front of the x squared term, that's 1. B is 8, and c is -4. So when I go b squared, so that's 8 squared minus 4 times a times c. That's what, 64? And this becomes negative times a negative is plus 16. So that's 80. So what I found is that I have a positive number, which means I have two real roots. Okay, and what that tells me, meaning if my graph looks like this, okay, I know my y-axis, my y-intercept is -4. So this point is here. So my graph either goes like this or it goes like this. But I do know that it does have two real solutions, which are two x-intercepts. So solving these equations right here, these are a little bit different. Notice that this is x to the 4th power. What we talked about in class, meaning that that's going to cross the x-axis 4 times, not 2 like a quadratic. This being a quartic, x to the 4th power. Factoring that, we're going to solve this by factoring. And so I'm going to, what is x to the 4th power? And so that's going to be x squared times x squared. This is a minus and this is a plus. So that means both of these are negative. And what multiplies to be 4 but adds up to be 5? So that would be -4 and -1. What I do notice is that both of these two quantities are differences of two squares. So this one is x plus 2 and x minus 2. And this one here is x plus 1 and x minus 1. So when I split this up, I'm actually going to have four solutions. I'm going to have x plus 1 equals 0, so x equals negative 1. I'm going to get x minus 1 equals 0, so x equals 1. I get x plus 2 equals 0, so x equals negative 2. And I get x minus 2 equals 0, so x equals 2. So putting my answers in solution sets, I'd have negative 1, 1, 2, and negative 2. So I could also write that as plus or minus 2. And really, just to get an idea of what this graph sort of looks like, we can estimate. We've got a negative 1 value and a 1. These are x-intercepts. We have a negative 2 and a positive 2. So I know my graph crosses my axis in four different places. I also know that my y-intercept is 4. So my graph does come up like this. So I can sort of give you an estimate of what this kind of looks like, not knowing how far down it is going or going up, but I can assume that it's like that. For this problem, keep in mind, there is use substitution, which you can use. I'm not going to use the use substitution for this value, this method, but in x, to get x to the 1 power, remember when you're multiplying variables that have common base, you always keep the base and add the exponents. Well, this goes for this problem too, in that I know that x to the 1/2 times x to the 1/2 is going to be x to the 1 power. And another way of writing x to the 1/2 is just the square root of x, okay? So this is actually the square root of x times the square root of x, which is x. And then to multiply to be negative 4, but add up to be negative 3, we're going to use negative 4 and positive 1. I'm going to split these up. I'm going to get the square root of x plus 1 equals 0. Square root of x equals negative 1. Square root of x is equal to 4. And keep in mind, I do want to solve for x. So I am going to square both sides to lose the root. And I'm going to get x equals, hold on, that's a 2. That's a 4. So that's going to be 16. And also, when I square both sides here, okay, I'm going to get x is equal to 1. Now, what happens here, though, is when I'm making my solution sets to see what my correct answer is, I do have two solutions, but when I plug my answer back in here, the square root of 16 is going to be 4. So that is one of my solutions. But when I plug in 1 into the square root of x, you have to ask yourself, when is that going to be negative 1? It's not. So we call that an extraneous solution. So it is a solution. You do show, excuse me, that's a positive 1. We do see that we have two answers, but this one here being extraneous. Okay, so I want you to transform this into vertex form. The reason why I would want to find the vertex form is basically I'm trying to find out what the vertex is. I know my graph is going to have a y-intercept of negative 12. So that'll be down here at negative 12. I want to know what the vertex is. Now, I know the other day we were finding the vertex by using the shortcut method, which was negative b over 2a, comma, and then we plugged in negative b over 2a and got the answer, or got the vertex. Whoops. I don't know if I can. Okay. Anyway, this time we're going to do this by completing the square. So that means that I keep the y, meaning if I want to find the x-intercepts, I'm going to set y equal to 0, okay? But I'm not asking you to find the y-intercepts or the x-intercepts. So therefore, I'm not going to set y equal to 0. Y stays. So completing the square, first step, we're going to isolate the x's. So we're going to get y plus 12 is equal to x squared minus 6x. And then in order to complete the square, two things have to happen. Number one, this value here, the coefficient in front of the x squared term has to be 1. So therefore, in order for this to be 1, which it is, so we're good. We're going to take half of the b term. So we're going to take half of the b term, which is -3, and then we're going to square it. And so half of -6 is -3. I'm going to square that, and then I'm going to get 9. I'm going to add that to both sides because it is an equation. And whatever I do to one side of the equation has to happen to the other side of the equation. So now what we have is y plus 20, and this is going to be x minus 3 times x minus 3, which we're forcing this to be a perfect square. By completing this square, this is always going to happen, x minus 3 quantity squared. So we get y plus 20. We're going to get y equals x minus 3 quantity squared minus 20. This is what we call vertex form, and therefore my vertex is going to be 3 comma negative 20. Okay, so over 3 down 20 is my vertex. So that basically means that my graph is going to come up like this, and then it's going to come around like this. Okay, now I'm not asking you for the x-intercepts. I could ask you for that on the test that we're going to be having, but right now I'm only asking you for the vertex. I may also ask you for, let's say, the axis of symmetry. So keep in mind, the axis of symmetry is also this line that cuts my graph in half, where the graph is symmetric on both sides. That is an equation. So that's going to be x equals 3. And you find the axis of symmetry, okay? You find that by this value right here, which is your x coordinate. So it's going to be x equals. If your line is vertical, it's always x equals. Again, now this one, I'm asking you to solve the quadratic. Where here, I didn't ask you to solve the quadratic. I asked you to find the vertex. Okay, so when I'm asking you to solve the quadratic, I'm asking you to find the x-intercepts. And another way to say x-intercepts are roots or solutions. So any one of these I could say, and what I'm really saying is solve the quadratic. So again, if I want to find the x-intercepts, note to self, set y equal to 0. So this here being y, okay, you're going to plug that in. 0 equals 3x squared minus 9x plus 1. Now, we're going to solve the quadratic by completing this square, which basically means we're going to move this 1 over to the other side. So we get -1 equals 3x squared minus 9x. So I isolated the x's, those are together, but I can't complete the square with this value right here. So what I can do is I can factor that out. And so I have x squared minus 3x. Now, I do want to complete this square. This one's a little bit awkward because it's not an even term. So keep in mind, when I'm asking you to complete the square, a short review, so I'm going to go off on a little bit of a tangent. If I had x squared plus 6x and I wanted to complete this square, finish this value here, half of 6 is 3, 3 squared is 9. I would add 9. If I had x squared plus, let's say 5x plus something, half of 5 is 5 halves. When I square that, I'm going to get 25 over 4. Just leave it as a fraction because I think that makes it easier when you're factoring. So when we take half of 3, that's going to be 3 halves. And then I'm going to square that. Now, even though this is negative, when I square it, remember, it's going to be positive. So that'll be 9/4. So I'm actually adding 9/4 to this side. But keep in mind, if I factored out the 3 has to actually come back in before I can add it to both sides. And so that's going to be 3 times 9 over 4, which is what? 27/4. So factoring, we're going to get 3 times x, and then this is a minus, so that makes that minus. This value here, square root of that is what? 3 halves. 3 halves times 3 halves is 9/4, 2 of those. And then for this, I'm just going to make this a 4 over 4 so that I get a common denominator, okay? So 27 minus 4 is going to be 23/4. Now, I still haven't solved the problem. What I need to do, hold on a second, let me get this over here. What I'm trying to do is I'm trying to solve for x. So keep that in mind. And for me to solve for x, which is basically finding the x-intercepts, I have to isolate the x equals. So first of all, I'm going to get rid of this 3. So I'm going to divide by 3 on both sides, okay, which is also the same as multiplying by 1/3. And so now I have 23 over 12 is equal to, that's gone, the quantity x minus 3/2 quantity squared. I'm going to square root both sides to get the x out of this root. And so now I have x minus 3/2 equals that, plus or minus this whole thing, 23/12. Now, I get that this is not a nice problem, but all we have to do now is isolate the x. So we have x equals, move this negative 3/2 to the other side, becomes positive 3/2, plus or minus the square root of 23 over 12. Now, I would, of course, never leave a root on the denominator, but for the sake of this time in this video, that's what I'm going to leave it like that. When you simplify this, you're looking for your x-intercepts. So you're going to need some numbers that you can actually graph. At some point, we know this graph goes through the x-axis, or excuse me, the y-axis at 1 being my y-intercept when x equals 0. Not sure if the graph is going to go this way or this way. Okay, so we're back to complete the square to solve the problem. So again, I'm looking for the x-intercepts. So I want to set, so the first step that you need to do is set y equal to 0. So we already did that, y is equal to 0. So we're going to use completing the square method. So again, we're going to go 2x squared plus 8x is equal to -5, okay? Now, again, completing the square, I cannot have a number in front of my x squared term. So I do need to factor that out. So I have x squared plus 4x. Now, to complete the square, I have half of 4. So take half of 4, which is 2, and then I'm going to square that. So that's 4. So I'm adding 4 to this side. But keep in mind, what I really added was not 4, but 2 times 4, which is 8. So we've got 2 times x plus 2 times x plus 2 is equal to 3. And I'm going to simplify that. X plus 2 quantity squared equals 3. Remember, I'm still trying to solve for x, so I'm going to divide by 2. So I have x plus 2 quantity squared is equal to 3/2. Now I'm going to square root both sides to lose the root there. And you guys remember that a root is a half power, okay? And so, hold on. A root is a half power. And so on the side here, a half power, when you square a half power, those cancel and you end up getting 1. That's what happens here, okay? You have x plus 2 is equal to plus or minus the square root of 3 over the square root of 2. Let's just simplify that really quick and lose the root on the denominator. And so that's going to be plus or minus the square root of 6 over, 2? And then, I don't like the way that wrote. So we have plus or minus, and then move the 2 to the other side. So we have x equals -2 plus or minus the square root of 6 over 2. Still don't like that. Just for fun, let's just figure out the square root of 6 is about, let's see, square root of 6 is about 2.5. 2.5 divided by 2 is 1.22. So this is really, what they're really saying is x equals -2 plus or minus 1.22. So remember what we're trying to do is solve the problem, which is finding the x-intercepts. So in doing that, I can say -2 plus 1.22, and I get the values x equals solution set -0.78 and -2 minus 1.22, and that's -3.22. So basically, if I were drawing a graph of this equation, I'd have a pretty good idea of what this looks like. I've got a value at -7 and at -3, -0.7 and -3. And I also know that my y-intercept is 5. So basically, my graph does look like something like this. Goes through that. Kind of. Okay. Convert to vertex form by finding the vertex. This right here is vertex form again. My vertex, again, is in the form of HK. Okay, notice opposite, same. First step is move the 7 over. So y minus 7 equals 2 times x squared minus 10x. Half of 10 is 5. 5 squared is 25. I'm going to add not 25, but 50 to both sides. I go, and 50 comes from this 2 times 25. So I have 2 times x, this minus, negative times negative is positive, so minus 5, quantity squared. And here I have y plus 43. So I get y equals 2 times x minus 5 quantity squared minus 43. So my vertex is equal to 5 comma negative 43. So if I were graphing this, let's see here, 1, 2, 3, 4, 5. Let's see, 43 is probably way down here. So that's my vertex. Keep in mind, my y-intercept is 7, which is up here, okay? So graphing, my graph will, okay, I'm trying to graph this, whoops. Let's see, come down this way, come up this way, okay? Goes through here at positive 7, and this is my vertex, which is 5 comma negative 43. Okay, negative 43 being way down here. I would ask you for, let's say, the axis of symmetry, which is right here. Keep in mind, makes it symmetric. Again, it's this x equals x coordinate. So this right here is my axis of symmetry. Okay. Recap on imaginary numbers. I would expect you to do this on your calculator. So that's something that you would need to do. Find the zeros. When I'm asking you to find the zeros, again, I'm asking you to find the x-intercepts. The first step to finding the x-intercepts, again, is to set y equal to 0, which it already is. So we're good with that. And you can trace on your calculator. So doing that, that's something you can do on your own. This right here is just a recap on imaginary numbers. So let's practice. We have 5 minus 4i times 5 minus 4i. We're going to FOIL, so we get 25 minus 20i minus 20i plus 16i squared. So remember that I squared is equal to negative 1. And so with that thought in mind, this right here becomes negative 1 here. So this becomes 25. So you have 25, what, minus 16, which is 9. So we've got 25 minus 16. So we have 9 minus this right here, 40i, and we're done. This one right here, remember that you can't leave a root, or a root, of course, but also you can't leave any imaginary numbers on the denominator. So I'm going to multiply by what's called the conjugate. And the conjugate is this value, 2 minus 3i over 2 minus 3i. So I get 4 minus, I'm distributing on top here, 6i, and this is over. Foiling the bottom, I'm going to get 2 times 2, which is 4. And then remember, the whole reason for multiplying by the conjugate is that that middle term cancels out. So you have 4 minus 9i squared. See, 2 times 2 is 4, minus 6i plus 6i. So what I'm doing here is minus 6i plus 6i. That's the middle term that cancels out. So I'm left with 9i squared. 9i squared, again, is negative 1. So this is 4 minus 9 times negative 1, which is basically 4 plus 9. So this final answer here is going to be 4 minus 6i all over 13. And that's your answer. Box that up. You don't put your answers in solution sets because these aren't equations. And so if they're not equations, you don't have solutions. You're just simplifying an expression. Here, so it's okay to use arrows, but don't just come up with an equal sign when there isn't one already there. So let's see here. 5i quantity squared is actually 5i times 5i, which is 25i squared. I squared is -1, so 25 times -1 is -25. And then this is just 3 plus 4i. And that's my answer. I could box that up. I also, keep in mind, I can distribute this 25 to both, like split it up. I can have -3/25 plus 4i, or actually that's a minus if I distribute the negative sign too, which is 25. This one is, remember, just a little recap. I is equal to the square root of -1. I squared equals -1. That's when I square both sides. I cubed is equal to I squared times I. And then I to the fourth is equal to I squared times I squared. Now, I squared is -1. So what that's really saying is I to the fourth is equal to -1 times -1, which is 1. So any time I have a multiple of 4, I'm going to get 1 as my answer. So like if I had I to the 8th, remember, this is I to the fourth times I to the fourth, which is just 1 times 1. So you would need to ask yourself, how many 4s can I take out of 237? So I think I can take out, 59. So 59 times 4 is what, 236? So this is actually rewritten as I to the 236 times I to the 1. This value right here is 1. So I have 1 times I, which is just I. So that answers I. Okay, this one is asking me to write each equation in this form, which is, remember, vertex form. So that means that I do want to complete the square to label the vertex. But this is asking me to do all of this extra stuff here. Discriminant, axis of symmetry, and x and y intercept. So, okay, let's get started. First of all, my y-intercept, okay, set x equal to 0. X equal to 0. That's gone, that's gone. My y-intercept is 29. So that's way the heck up here. We'll call that 29. In order to put it into vertex form, okay, let's do that next, okay. I'm going to go y minus 29, move this over, equals 2 times x squared plus 8x. Half of 8 is 4. 4 squared is 16. So keep in mind, I'm going to, let's see here, simplify. Oh, and if I added not 16, but 2 times 16 to this side, I do also need to add 32 to this side. So I have 2 times the quantity x plus 4 squared, and what's that, 3? Y plus 3. So my vertex form is y equals 2 times x plus 4 quantity squared minus 3. So my vertex is going to be the opposite of this, which is -4, comma, and then this value, same, -3. So -4, -3, we'll say is around here. So that's my vertex. So right now, I do know my graph is going to come up. Sorry about that. Let me move this over a little bit. Okay. And so I do know my vertex is going to look, or my graph is going to look something like this. Okay. Now, I also know my axis of symmetry, which is going to be this value here. So x equals -4. All right. I know that because the graph cuts right through here, that being -4, comma, -3, it's going to cut right through there at -4. My discriminant, which is b squared minus 4ac. This one, b squared, so go back up to the beginning, this equation right here. b squared, so that's what, 16 squared minus 4 times a, which is 2, times c, which is 29. So that's going to be 256 minus, let's see here, 4 times 2, which is 8 times 29. And that becomes 24. So remember the rule for, this is the discriminant. Remember the rule, and the rule is if this is a positive number, we have two real roots or x-intercepts. If this was negative, I would have 2 imaginary intercepts, and if it was 0, then I would have meaning if this was 0, my graph would actually just touch once, right? Just like something like that, okay? All right, to find everything, we got the y-intercept. Oh, I don't have the x-intercepts. So let's just complete the square to find those. I mean, I could factor if this factors. This is not going to factor nicely because that's not a perfect square. We don't want to do this. I guess we can just do it this way because since we already have this almost done, let's just set y equal to 0. So then I have to find the x-intercepts. I can go right from here. Actually, I'm going to use this value here and go right from here to here. And I'll set y equal to 0 to find the x-intercepts. So I'm going to have 3 is equal to 2 times x plus 4, quantity squared. I'm going to divide by 2. I get 3 halves equals x plus 4, quantity squared. I'm going to square root both sides, and I get x plus 4 is equal to plus or minus the square root of 3 over square root of 2. Again, I'm going to get rid of this root here down on the bottom by multiplying by root 2 over root 2. So my final answer is negative 4 plus or minus the square root of 6 over 2. Now, I actually want to know what those numbers are, okay? I would put those in solution sets, but I do want to know approximations of what the two x-intercepts are, because since it's asking me what they are. So I would go negative 4 plus the quantity, the square root of 6, okay, divided by 2. And that's going to be negative 2.3. And then I'm going to go negative 4 minus the quantity, the square root of 6 divided by 2. And I'm going to get negative 5.7. So negative 5.7. So these are actually my approximations to these two values. And verifying this, I've got negative 2.3 here, okay? And of course here would be negative 5.7. So those values are there. Cool. So putting it all together, here's my equation. I want it in vertex form, so I need to complete the square. I need to find the vertex. We know the y-intercept is negative 7 right off the bat. That's pretty simple. X-intercepts, I'm going to have to set that equal to 0. It's not going to factor. So we haven't used the quadratic formula, and it does say use the quadratic formula. So let's find the x-intercepts by doing that. X equals the opposite of b, so that'd be negative 16 plus or minus b squared, so 256 minus 4ac, and that's all over 2a, so 2 times 1. Okay, and so in doing that, hold on. All right, so we have x equals negative 16 plus or minus, let's see, what would be 256 plus 28? And that's going to give me 284. Square root of 284 is approximately 16.9. So this is 284 over 2. So I'm going to do approximations. So we have x equals, so we got x equals negative 16 plus the square root of 284, which is 16.8. So one of my values approximately, so I'm going to go little approximation signs, is going to be 0.8. Oh, wait, did I divide that by 2? No. Divide that by 2, and that's actually 0.4. Let me erase that. Okay, so one of them's 0.4, and then I'm going to go negative 16 minus 16.8. Divide that by 4, and I get negative 8.2, comma. So these are my approximations. This is the value of my x-intercepts, okay? So we're going to say negative 0.4 and then negative 8 something, okay? To find my, so those are my x-intercepts. All right. To put this in vertex form, I'm going to add 7. So I get y plus 7 equals x squared plus 16x. I don't have to factor any values out here because x squared is 1. So I just have to complete the square. Half of 16 is 8. 8 squared is 64. So I'm going to add 64 to both sides. This was a 7. So that's going to be y plus 71 equals x plus 8 quantity squared. So y equals x plus 8 quantity squared minus 71. My vertex is negative 8, negative 71. So at negative 8, negative 71, so I'm way down here somewhere, okay? I do know that my axis of symmetry will be x equals negative 8. Graph is going to look something like this. It's going to go through here, and of course, oh, that says 0.4. Hold on one second. Move this over here. There we go. I saw that being an issue because if my y-intercept is negative 7, it's got to go through wherever negative 7 is. It's going to come up like this, go something like that. The discriminant being b squared minus 4ac, that's this value here inside the root. So I already know that that's 284. I do have a minimum because it does have a low point, so my minimum. My domain is going to be negative infinity to positive infinity. And my range goes down here to the lowest value, which is negative 71, including negative 71. Therefore, it's a bracket, not a parenthesis. And then it goes up to infinity because it's always going to keep going up there. Okay. So that's actually where we left off in class. So thank you. I hope that helped you. Thank you.